Hello, you are most welcome. I'm teacher Ivan from Una Educational Services. Today we shall be looking at how we find the equation of a straight line. But before we find the equation of a straight line, please, I request you to subscribe to all our YouTube channels from Una Educational Services, which include Teacher Ivan's online class, Una e-learning platform, and the Una Kids platform. Don't forget to hit the bell so that you get notified whenever we have new videos. Thank you. So, the general equation of a straight line is given by y equals to mx plus c, where m is the gradient and c is the y-intercept. That means that for us to find the equation, we must find the gradient and the y-intercept and substitute in the general equation. For instance, if you look at this equation, 2 over 3 is the gradient m and negative 1 is the y-intercept c, meaning x and y are constants in our equation. So our task is to find the gradient m and the y-intercept c and substitute them in the general equation. How do we get these two? Let us start with the gradient of the line. The gradient of the line is defined as the ratio of the vertical displacement to the horizontal displacement. This is what I mean. If we have 2 points A and B lying on the same line, then we shall get their vertical displacement and the horizontal displacement. The vertical displacement is given by y2 minus y1, and the horizontal displacement is given by x2 minus x1. Hence, the gradient of that line is given by y2 minus y1, which is the vertical displacement, over x2 minus x1, which is the horizontal displacement. For instance, we may be told to find the gradient of the line that passes through points negative 1, 2, and 3, 0. So, these are the 2 points that lie on the same line. And for us to find the gradient of the line that passes through these points, we shall name our points. We can name this x1, y1, x2, y2. The first value is always an x-coordinate. So that means that the gradient m is given by y2 minus y1 over x2 minus x1. Hence, we substitute. Where we have y2, we substitute with a 0 minus. Where we have y1, we substitute with 2 over x2, which is 3, minus x1, which is negative 1. Hence, we shall end up with the gradient being negative 2 over 4, which is negative a half. So that is how we shall get the gradient of the line. Then, after getting the gradient, remember we are finding the equation of the line, which is in the form of y equals to mx plus c, where m is the gradient, c is the y-intercept. So, we have the gradient. Now, our task is to find the y-intercept. So, after getting the gradient, which is negative a half, we now look for the y-intercept, C. How do we do this? For y-intercept C, we shall consider one of the points and the gradient. And this is what I mean. Since we have our gradient as negative a half, then we have our 2 points, which is negative 1, 2, and 3, 0. So, remember the equation we are finding is in the form of y equals to mx plus c. We so far have the gradient m. We are looking for c. For us to look for c, we shall consider the gradient and one of these 2 points. For instance, I will consider negative 1, 2, whereby this will be our x value, this will be the y value. And then substituting this equation, since we have y equals to mx plus c, then where there is y is where I will substitute with a 2 equaling to m, which is negative a half, times x, which is negative 1, plus c. So that I remain with 1 unknown, hence giving me 2 equaling to negative 1 times negative 1 is 1 over 2 plus c. So I will get c by collecting like terms, which is 2 minus a half equaling to c, hence giving me c as 1.5 or 3 over 2. So this is my y-intercept. Now that I have the y-intercept and I have the gradient, therefore I will get the equation of the line, which is from y equals to mx plus c, then I substitute for m and c. So I have y equals to negative a half xc plus 3 over 2. That is the equation of the line. So, in short, for us to find the equation of the line, when given 2 points, we first get the gradient, which is given by y2 minus y1 over x2 minus x1. After getting the gradient, we consider one of the 2 points and the gradient to find the x-intercept c. Otherwise, that has been our lesson. Please don't forget to subscribe, comment, like, and share with friends, family members, classmates, and colleagues. Thank you. Bye-bye.